Hello and welcome to a very zoomed in edition of the Daily Space for September 5th, 2018. I will be readjusting this camera view before we do this again. Um, for all of you who were here yesterday when I decided I needed to mispronounce everything, shortly after the broadcast, I went to the doctor and found out that a bike crash I had had led to much worse injuries than I had previously assumed. And my inability to speak coherently yesterday was due to me being silly and not going to the doctor and trying to record while in pain. Thank you all for sticking around. I am in better shape now. Now for today's news. In our first story, we have a case of trying to understand why it is that some active galactic nuclei twinkle and vary in brightness more than others. It turns out to be a function of how much they've been feeding. This is new results by Paula Sanchez Saez, who is a doctoral student at the Universidad de Chile. And that was mispronounced because I don't know how to pronounce it. Um, in this work, which is done by an amazing young scientist, what they have done is very carefully look at what possible relationships there can be between how quickly a supermassive black hole and its surrounding regions, it's more the surrounding regions, appears to vary in brightness versus how much the accretion disk is feeding material into that central supermassive black hole. It turns out that when we see a black hole that has a surrounding accretion disk that is varying a lot in brightness, this is because it doesn't have a lot to eat. So as material slowly, not very steadily, falls into the black hole, as the disk, which isn't very full of material, fails to feed its black hole, we see the area around the black hole flickering in brightness, varying in brightness, and these changes in luminosity are actually something that we can really take advantage of, because by studying how quickly it brightens and then dims back down, we can get a sense of the size of that central region of the active galactic nuclei. This is called echo mapping, and it gets used around flare stars. For instance, some of you may remember V838 Mon, a star that flared into everyone's attention back in 2002. And as the flash of light from the core star has moved through this very rich and complex cloud of material around the star, it's illuminated the surroundings, and we can see the material behind the star get illuminated after the material in the foreground of the star, because the light has to travel backwards and then reflect forwards. Well, we have the same kind of lag in accretion disks in the hollows in the centers of active galactic nuclei. And we echo map things to the best of our abilities, and now we know the more flickering, the less feeding is occurring. This is not our only story involving black holes today. We have another story that helps us understand the centers of not just active galaxies, but all galaxies that have this supermassive black hole in the center. Now, we used to think that all galaxies, full stop, all galaxies, had a massive black hole that was tens of thousands to millions of solar masses in its center. The mass of this black hole was tied to the mass and velocity distribution of the surrounding sphere of stars. Now, giant ellipticals are pretty much all sphere, and they have giant supermassive black holes. galaxies like our own, which are spiral galaxies that do have that bulge in the center, have smaller supermassive black holes to go with our smaller spheroid of stars. Now, it turns out there are galaxies out there that are pure disk, and these pure disk, flat, rotating systems don't really have a spheroid and don't seem to necessarily have a supermassive black hole in the center. Now, for all the rest of those systems that do have that sphere in the center, that do have that supermassive black hole, it's now thought, based on observations of our own Milky Way galaxy and a variety of models that have been done. Sorry, I'm looking to see exactly where this was because I need to look at the name. This is Otiv Lorand University. It is thought by students at this university that it just might be that these systems have a whole disk of black holes down in the core. Work by Andrea Getz has shown us over and over that there is a disk of stars that she's able to detect that are rapidly moving on orbits as small as Pluto's orbit around this supermassive black hole. New results looking for X-ray emissions that could be tied back to X-ray binary systems have shown that there are also, well, dozens of X-ray binaries down in the core as well. And where you have X-ray binaries, this is a black hole and a secondary star that is getting cannibalized by that black hole. Where you have binary systems with black holes, you also have a large population of just black holes hanging out by themselves that aren't necessarily as easy to discover. Now, with these X-ray binaries, with the predicted density of regular stellar mass black holes, it is looking more and more like the centers of galaxies have not just a supermassive black hole, but potentially thousands, that's one with 3 zeros, thousands of black holes orbiting in a disk around that supermassive black hole. So you may have heard the phrase, it's turtles all the way down. Nope, it's black holes all the way down, at least when you're looking at the centers of galaxies. So this was work, once again, done, I'm going to destroy this pronunciation, at Eötvös Loránd University. This is a university in Hungary. And once again, this is work being done by a PhD student. So this is to show you that amazing results can come from young scientists who work hard and discover awesome things. Now, in our next piece, this isn't so much a research result that's cut and dried as a research into doing research result that is probably going to get argued. The National Academy of Sciences, Engineering, and Mathematics has released a new study on exactly what strategies should be adopted by the United States in order to advance exoplanet research. Here they are recommending that NASA should not only continue development of the W-FIRST spacecraft, which was the #1 priority in the last astronomy decadal study, but it should in general also invest resources, energy, and time into the long-term construction of a space telescope capable of directly imaging Earth-sized planets orbiting in the habitable zones of nearby stars. This is part of a building sense of how we need to move forward, where we have telescopes such as the recently launched TESS that are hopefully out there detecting new worlds that we weren't able to detect with the very specifically focused Kepler mission. Kepler is a spectacular spacecraft that between its original mission and its K2 mission has been able to detect stars with planets orbiting around them that transit in front of the star. And all of these detections have taken place in a limited place on the sky. With Kepler, we essentially sampled for planets through a core sample of the visible parts of our galaxy. So this means that, well, because we're looking at an expanding cone as we look at the same region on the sky at greater and greater distances, there aren't that many planets that have been found very near to Earth. As we look at things further and further away, we're sampling larger and larger volumes, we're finding more and more planets. Well, TESS is taking a different approach. TESS is slewing around, redirecting itself at star after star after star, looking to do a census for planets of all the nearest stars. Once it's able to identify these, instruments such as WFIRST will be able to do follow-up observations that bring us an even better sense of what is around these nearby systems. We also have an increasing wealth of planet-bound detectors able to do things such as measuring the atmospheric compositions of these worlds. Now, what we don't have is the ability to directly image planets that are Earth-sized and not necessarily super close to their star. The James Webb Space Telescope, when it launches, should be able to do an amount of direct imaging working in the infrared. Well, with this research in how we can better do research from the national academies, they say that to continue our study, to do better as we move into the future, what we really need to do is build on this legacy, to continue increasing our detection capabilities, to move from TESS to WFIRST, and move on to a new, as yet to be imagined, direct imager. This is a fabulous roadmap, and it is something that you can get from the National Academies. Unfortunately, there is a fee to download the full PDF, but your page charges go to continued funding of this work and others that are being done by the National Academies of Science, Engineering, and Math. Now, my last bit to bring you isn't so much a this is what has been done as a tune in on Friday at a special time to learn more. This week and for, well, the upcoming future, we're going to have Dr. Andreas Plazas covering every Friday's daily space as we bring back Astronomy Cast. So what you can look forward to on Fridays is at noon Central Time, 1 p.m. Eastern, 6 p.m. London time. That is 10 a.m. out in the Pacific, the Daily Space, every Friday by Andreas Plazas. We will then have at 3 p.m. Eastern, which is noon Central, 9 p.m. London, no idea what time in Australia, we will have over on YouTube the return of Astronomy Cast. Now, this Friday, we have a special event in between the two that Andreas will be covering, and this is a press conference by NASA to sum up the amazing science that has come out of the Dawn mission. This little spacecraft that is actually powered by an ion drive, it first went to the world Vesta. From Vesta, it went on to visit Ceres. These two asteroids are on either side of our asteroid belt's waterline. Vesta on the inside is a dry asteroid. Ceres on the outside is a wet world that still appears to have amazing salt water coming out of its surface through some kind of process, probably some form of cryovolcanism that we're still working to figure out. So tune in Friday to get the latest from NASA with commentary and answers to your questions right here on CosmoQuest X on Twitch. So that is at 1 p.m. We're going to have the Daily Space going into the NASA press conference, and then at 3 p.m. on YouTube, Astronomy Cast. So Welcome back. This is the week that we bring back all of our sister shows spread out all across, well, the social media channels. So here we have Learning Space on Twitch. I will be here on Thursday. I have a very special guest that I'm very excited about, whose name I have forgotten because I've been looking at all the names for fall. Tune in to the wshcrew.space. They list everything. And they also tell me what I'm doing, which is the more important part. Wednesday night, the Weekly Space Hangout, hosted by Fraser Kane, Morgan Reinberg, and Kim Cartier will be back on YouTube. And on Friday, we're bringing back Astronomy Cast. And I believe Fraser also has a virtual star party at a time I don't remember. So it's all the science you can eat, drink, and enjoy. So I am now going to take your questions. First, I'm going to scroll through and see what all is in the chat. Fellow Hoodlum, thank you for the 2 bits. Now I have song lyrics stuck in my head. So I see Hanny asking, how long will it spend looking at each section? I'm assuming that what you're asking about is how long will Tess spend looking at each thing? Tess is actually going to be looking at stars one at another. So it's not looking at a region of space so much as it's looking at this star, looking at this star. And its duration, I believe, is going to be a function of brightness of object. As always, Nightbot has my back and is telling you all the times for all of the things. I like Nightbot. So thank you, Susie, for putting the link up for this Friday's Astronomy Cast. Our topic will be the resolution to rename Hubble's law to the Hubble-Lemaître law. So yes, Larry, Tess does the whole sky, but only looks at the nearest objects. And Guido, oh, there's no Weekly Space Hangout premiere tonight. I lied. Thank you for correcting me, Guido. So the Weekly Space Hangout will be back. I don't know when it will be back. Next week? Guido can probably tell you. So do we have any other questions out there? I will go ahead and try and recenter this camera a little bit better. There we go. So, as always, the Daily Space is part of CosmoQuest. I invite all of you who have screen real estate to go ahead, click on over to cosmoquest.org. Check out all the worlds we could use your help mapping. We have detailed imagery, and it turns out computer algorithms cannot yet do things like finding craters. So we'd like to borrow your brains if we can and get some help marking out what's in these images. So I see Hanny asking, if there tends to be black holes near the galactic center in X-ray binaries, can we expect any collisions soon? I don't know. Even though it's quite dense in there, saying that we can expect black holes to collide with other black holes if they're all in one disk, I'm sure someone has calculated it. I don't know the answer, but since it's a disk, I'm going to assume that even though there are lots, just like there's lots of asteroids, we don't generally worry about asteroids colliding in the asteroid belt because while there's thousands of them, they're not spatially dense on that scale. And I expect we're looking at something similar. Black holes, stellar mass black holes, aren't that big. So I don't think we need to worry. The one place where we worry about collisions is in globular clusters where orbits are very randomized. Okay, so Guido is saying the Weekly Space Hangout premiere date is not yet confirmed. confirmed. But Ton Van Scooter is saying that Skylius and Fraser are having a virtual star party tonight starting at 9 p.m. Pacific. Is that on Fraser's YouTube or Skylius's Twitch or both, Tom? Knowing where people could log in would be greatly appreciated. Um, oh, and as much as I love Nightbot, Automod has a problem. I'm not sure why Automod felt the need to block Dawn in all caps. I didn't know the word Dawn could be aggressive, but apparently it can. Um, okay, so we're looking for Skylius Twitch. That is perfect. Okay, so tune in to Skylius's Twitch channel tonight for a virtual star party. So if there aren't any more questions, I'm going to let everyone get back to their day. And now I see people trying to trigger Automod, which has now been trained not to block the word dawn. So, Graham, if they're not, I just heard that the weekly space hangout isn't going tonight. I'm very confused. Okay, go to wshcrew.space. They will keep track of everything for you. And I'm just going to be confused while Susie unconfuses me. So I'm not seeing any more questions. So I'm going to go ahead and invite all of you to have a fabulous day wherever you are in the world. And thank you for coming. Thank you for your support. As always, if you give us a follow, you will be notified whenever we go live. It turns out that we have a lot of random programming over on this channel, as well as our everyday programming. We don't have Astro 101 today, just because we're still all trying to catch up from, well, me confusing the entire program by falling off of a bicycle. So stay tuned for tonight is Wednesday. Stay tuned over on Skylius's channel for the virtual star party. Check out wshcrew.space to find out if we have the weekly space hangout tonight. And tomorrow we will have the daily space followed by learning space. And Friday, we will have Daily Space, followed by a NASA press conference, followed by, over on YouTube, Astronomy Cast. All the science is yours. We are sustained through your subscriptions, and every bit really counts. So if you want to see it all happen, well, please give us a subscription. So that's all I've got. And we have, not this weekend, but next weekend, the Astronomy Cast 500th episode. And I'm looking forward to getting to meet many of you in person. So thank you. Thank you for being here. Thank you for supporting us. And wherever you are in the world, have a fabulous morning, evening, or afternoon. Bye-bye.